Hello everyone and welcome to this product presentation of the new and renovated local verifications environment. The utility menu inside the local verification environment is going to provide us with a vast array of tools to calculate diverse types of elements inside the Tremuri program. So if we click on utility, we are going to see that in the second drop-down list I'm going to be able to see all the different types of verification that I can perform in the local verification environment, such as, to begin, first the reinforced concrete verification that we can perform in these diverse types, such as cracking, bending, axial bending, or shear. For example, if I click on cracking, the toolbar is going to appear and I'm going to be able to create a new item. As I can see here, I can insert all the data, all the geometric parameters of this section, and I'm going to be able to perform the calculation. Another reinforced concrete verification is going to be the bending and axial bending verification. As I can see here, I can set all the longitudinal reinforcement, all the characteristics of the cross section and the forces and the type of member that I want to verify into bending, such as beam and column, and the type of design that I want to perform in that element. I can go ahead and click on calculate to calculate that element into that specific set of forces. And also, lastly, the reinforced concrete verification of shear. If I create a new item, I'm going to be able to see a specific window with all the parameters that I can insert to perform this verification. Another verification of reinforced concrete is the specific to structural reinforcements, such as bending. As I can see here, if I click on create new item, I can insert all the parameters, the characteristics of the reinforcement, and perform the calculation to the bending stress with a reinforcement. Also, axial bending. As I can see here, I go ahead and create a new item. I'm going to be able to perform an axial bending verification on elements with longitudinal reinforcement or wrapping. As I can see here, I can set all the forces, all the characteristics of the reinforcements, and perform the calculation. And I can perform the verification of reinforcements with the shear stress. As I can see here, I can set up all the parameters and click on calculate to perform the verification. Moving on with the possibilities of the utility module, I can go into the loads analysis. In this case, I'm going to go for a floor load that is going to allow me to choose between the list of different materials, surface loads, and variable loads to perform a specific load calculation with those characteristics. Another option is the wind calculation that if I click on create new item, it's going to make available the calculation for the wind loads in a specific structure. As I can see here, I can just navigate through the different tabs of the window and input the general parameters, the walls, the roofs. For example, if I have multiple roofs, if I have buildings with a circular layout, also the calculation of roofs, solid beams, and towers, and perform the wind load calculation on those types of structures. Lastly, in the loads analysis menu, I'm going to be able to perform the snow calculation. And as I can see here, I can perform the input of all the characteristics of the structure and the area where the structure is located. And this is going to give me the snow loads for that area. Another option is going to be the concrete tests that it's going to be able to perform the calculation with all the information from from diverse types of reinforced concrete tests that I've done, and it's going to be able to give me, with all the information that I input, I'm going to be able to calculate the average resistance, with safety coefficient, and some other parameters that I can see on the screen, depending on the type of test that I want to perform. Regarding the steel connections, I can perform the verification of welding connections. As I can see here, I can calculate and verify diverse types of weldings, such as elements welded in parallel, elements welded perpendicular, and welded sections, like steel cross sections welded into a steel element. As you can see here, I can input all the parameters of the geometry and the steel used on the welding, and if I click on calculate, the verification is going to be made. Regarding the timber connections, I have, for example, the option to calculate carpentry timber connections. By clicking on new item, I can navigate through different types of carpentry connections, such as, for example, simple carving or back carving in these type of connections that I can see on screen, with a rafter with a bottom core, maybe a rafter with a side post, a rafter with a king post, and a rafter with a side post. Once I choose the type of connection and the dimensions, I can perform the calculation of this timber connection. I can do the same for the timbers connections that were made with nails, screws, and bolts, just by choosing the types of elements that are connecting, for example, steel and timber, a panel and timber, or two timber elements that are connected with each other. Again, I can input all the parameters, click on calculate, and the verification is going to be performed. Continuing with the verifications, I can perform geotechnical calculations, such as the calculation of piles. As I can see here, I can input all the parameters for the pile, and the calculation is going to be performed, and of course all the data from the tests of the soil. And if I click on calculate, the verification is going to be made and saved into the program. Another geotechnical verification is the K-winkler calculation, that, as I can see here, I can input all the foundation parameters, such as the geometric characteristics and characteristics of the soil, then the soil parameters with this side of the window over here, and I can perform the verification for different hypotheses of calculations, such as Terzaghi, Meyerhoff, Hansen, etc. Regarding the fire verification, I can perform the fire verification to flexion or axial bending stresses. As I can see here, I can go ahead and click on create new item, and the first thing that I need to do is to input the geometric characteristics of the section and the exposition, and the verification it's going to be done with the forces that I input, and it's going to give me the results once I click on calculate. The same procedure can be done for the case of axial bending verification, where I just input the geometry of the sections and the forces that are acting on the element. Another option is the calculation of water tanks. As I can see here, I can input all the tank characteristics, as I can see with the image on the right side of the screen, and some characteristics of the earthquake that is going to act on this specific tank, and it's going to give me a stress distribution on the whole tank. As I can see here, I'm going to be shown results of impulsive component, the convective component, and some other parameters that I see on screen. The possibility to calculate reinforced concrete beams made of steel and timber and reinforced concrete, such as standalone items, is also possible in the utility part of the local verification environment. And as I can see here, I just need to input a description for the beam, and then I'm going to choose the material, whether it's going to be made of reinforced concrete, steel, or timber, and I'm going to insert data from the loads, such as the distributed loads and concentrated loads that are acting on that beam, and of course, if I have concentrated moment applied to the nodes, etc. Also, I'm going to be able to choose between different codes to have the safety coefficients. And once I click calculate, the beam, it's going to be calculated in a standalone way. Another option is the local seismic response. That in order to calculate the local seismic response, I'm able to input a spectrum diagram that I have two ways of inputting. I can just do it manually, or I can just copy and paste from an Excel sheet in order to input the diagram that is going to be drawn in this area of the screen. Once I click on calculate, the program is going to calculate all the different parameters of that specific spectrum. Lastly, another tool that we have inside the utility menu is the calculation and verification of double bars. As we see here once we click new item, a double bar window is going to open up, and I'm going to be able to input all the specific data of that verification. And once I click on calculate, the element is going to be verified. And if we click OK, the element is going to be saved into the local verification environment. That's it for this presentation. Thank you everyone for your attention. And don't forget to follow us and subscribe to our YouTube channel to get access to our latest videos and tutorials.